the different properties that minerals have and how we can use those properties to figure out what mineral is what. So each mineral is going to have unique physical properties about it, and geologists can use these properties to identify a mineral sample. We have 8 properties in total. You don't need to list them now. We're going to go back and we're going to look at each one in more detail, so I would not list them twice. But know that each property can be used to identify a mineral sample. Alright, our first property that we're going to look at is color. Alright, so the color can give us some clues about the mineral, right? It tells us what it is. But the problem is with colors, the same mineral can come in several colors, right? Quartz can be clear, but amethyst is also quartz with just 1 or 2 tiny little impurities in it, but that makes it purple. So impurities in the mineral can cause our color to be unreliable. So color alone is not a good way to identify minerals. Also, more than one mineral can be the same color. Think about fool's gold. So we need some more ideas. Streak is the color of the mineral in powdered form. Right? So to find a streak, we rub the mineral against the streak plate. Right? And this will tell us some more information about the mineral. The streak of a mineral is always the same no matter what. So quartz will always have a clear streak, even if the quartz itself is purple. So the color of the streak is not always the same color as the mineral. For example, pyrite, fool's gold, even though it looks like gold, actually has a green streak, has a dark green streak. Because when it gets powdered, it loses its shininess and it shows a different color. The next thing we can look at is called luster. So luster describes how shiny a mineral is, right? And how reflective it is. Your book uses a bunch of terms like glossy and greasy and waxy. We're going to basically classify luster into 3 different types. It can be metallic, like this mineral here. It can be glassy, so it's kind of reflective, kind of like a pane of glass. Or we'll just call it non-metallic if it's not reflective at all. Our next property is density. Right. Density can be used to identify a mineral. We already know what density is. We talked about it in our metric unit. Right? It's a measure of how compact a mineral is. Right? And every sample of a particular mineral is always going to have the same density. So remember, styrofoam not very dense, brick very dense, and we calculate that by mass divided by volume. Hardness is our next property that we can use to figure out what a mineral is. The hardness refers to a mineral's resistance to being scratched. Right? Notice it doesn't say that the mineral can't be cracked or broken, right? Because we'll see that diamonds can be split, but they are pretty much cannot be scratched. So we use something called the Mohs scale to measure hardness. So minerals are assigned numbers based on how hard they are. 10 being the hardest, a diamond. Talc being a 1, the softest. And other minerals are given numbers in between. So any mineral can scratch a mineral with a equal or lower Mohs number. I'm going to change that real quick. With an equal or lower Mohs number. Right, so a diamond can scratch another diamond, right? But topaz cannot scratch diamond or corundum. Only the minerals equal or below it. So hardness can be really useful for giving us an idea of what the mineral is. Our next one that we can use is called a crystal system, and so we won't use this a lot in class because this is hard to figure out without some more advanced technology to really look at the crystal shape deep inside the mineral itself. But remember, we saw that each mineral has a crystal structure. The shape of that crystal structure can help us identify what a mineral is. All right, so you certainly don't need to memorize these different types of crystal structures. I'm not going to quiz you on hexagonal versus cubic or orthorhombic or anything like that. But know that this is something that can be used to identify minerals. All right, 2 more. We have cleavage and fracture. All right, and this describes how a mineral breaks. So if a mineral has cleavage, it means it breaks along nice, clean, flat lines for the most part. Right? You might have a couple areas that are a little messy, but in general, the mineral tends to break really easily. If a mineral doesn't have cleavage, we say that it has fracture, where it just breaks unevenly with no particular pattern. And our last thing that we can use is kind of a catch-all, and we'll just call these special properties. All right, not special properties. All right, so special properties are things like magnetism. Is it magnetic? Is it fluorescent? Does it glow under ultraviolet light? Most minerals don't have these that apply to them, but every now and again you'll have things like magnetite, which is magnetic, which can really just quickly help you figure out what that mineral is. All right, make sure we put 3 questions at the bottom. Enjoy your weekend, and I'll see you guys on Monday where we'll do a lab using these properties to identify different mineral samples.